Hi folks, so in this video I'm going to show you how to draw max-min lines. So here I have some data that I've described in some other videos. It's a tennis ball rolling down a slope with a constant acceleration. We know that displacement is proportional to time squared when something is moving with a constant acceleration. So that means that time squared should also be proportional to the distance d. So what I've done here is I've just processed my data. I have got some time values here that I've squared over here. Okay, so this is time squared in this column. I also did some error propagation and I worked out the uncertainty for time squared. I took the percentage uncertainty for time multiplied by 2 and then multiplied by the time squared value to get the absolute uncertainty of these time squared values. So then what I did, I went into Desmos and I drew time squared versus distance. And you can see that my data, as it should, it lies nicely on a straight line through the origin. So I can do the regression, right? So here is the best fit straight line modeling this data. And it's a pretty good fit going through all the windows of uncertainty, very close to the origin as well, as it should. But now I'm going to show you how we can draw the max-min line. So we want to, the best fit line has been given here. The slope is 0.03139 roughly, the y-intercept negative 0.0146 and so on. But I want to find the uncertainty of these parameters. So I want to try and draw some, the least steep line that goes through all these error bars and the most steep line that goes through all these error bars. And the way we do that, so it's a little bit annoying to do that, but it's also not that hard. So what I do is I start off drawing a line, say px plus q, and I create sliders for the slope and the y-intercept. And I can see that the slope is going to be around 0.03. So I can, for instance, say let's go from 0.02 to maybe 0.04 on this slider, and we go up in small steps to really sort of capture the variation in slope. You can see here is a line I can change the slope. The y-intercept is close to 0, so why don't I try 0.05, negative 0.05 to 0.05 in small steps. And if I change that slider, then I'm changing the location of the line, shifting it up and down, right? So let's say this is the, I'm trying to find the line with the largest slope that still fits my data. So I sort of just tweak the sliders. I can take away that line, by the way. You can see I'm trying to tweak the sliders so that I have the most steep line that still goes through the windows of uncertainty. I can sort of zoom in and check, yeah, it's going through that one, going through most of the others, and it just goes through the last one as well. So this seems pretty good as my max line with maximum slope. And then I just do the same, just use some other letters for these new sliders. And now I do the same. Let's just do it like that. So 0.02 to 0.04. Do this again. There is a reason I'm doing it, as you'll see, in this way. Okay, and then I want to try and find the least steep line, right? So I want to try and go up, and I want to make the slope really small, but I want it to go through all the windows of uncertainty. You can see it's missing that one, so I kind of need it to go a little bit more up. What about the others? Going through that one, going through that one. This looks pretty good. You're not doing a PhD in physics. It doesn't have to be super perfect, but try your best to draw some nice straight lines like I did now, max-min lines. Okay, now I can use these max-min lines to now work out another best fit line that is going to be very similar to the best fit line that Desmos gave me, but if I use, I can use the slopes here to work out the average slope. So 0.0322 plus 0.0294 divided by 2. So that is going to be the slope of my best fit line. And I can work out the uncertainty of that by just taking the range of those slopes and divide by 2. So you can see here I have the slope is 0.0308 plus or minus 0.0014. Okay, keeping 2 sig figs for this uncertainty because the first significant digit is 1. And then I can do the same for, well, it's relatively easy. You can see if I look at the y-intercepts, negative 0.05, 0.05, so that is centered on 0, plus or minus 0.05. So I can now I can draw my best fit straight line according to these max-min lines would be this line, okay, which I have right there. Now that doesn't look too good, but I can change the formatting of these lines, like my max-min lines. I like to make them relatively thin and green, for instance. Let's make them green and thin. And my best fit line, I can make that black and maybe also just a little bit thinner like that. And there you go. I have a pretty nice final graph here, right, where I've got my data points, I've got my error bars, I've got a best fit straight line, I've got max-min lines, I now have the slope with uncertainty, I've got my y-intercept with uncertainty as well. And again, I can export this image nicely and put that into my lab report. And there you go. That's how you draw max-min lines in Desmos.